Welcome, everyone. We'll be waiting 2 to 3 minutes to get started as a courtesy to those who are still in the middle of connecting. Welcome, everyone. Thanks for joining us and thanks for being part of our community. We have a great topic to cover today, but first, a few reminders. Please feel free to ask questions at any time by typing them in the IM window. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time, but I wanted to provide an additional mechanism to ensure that any questions we might miss get answered. If you'll visit aka.ms/Azure ATP community, you'll be able to ask a question right on our Azure ATP forum. If you're listening to this after the fact as a recording, that's also a great place to ask a question. And by the way, any of these links I'm referencing here are pasted in the IM window, so you can check them out there. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/AATP recordings. While you're there, please join our community by visiting aka.ms/security community. That's the best way to ensure you don't miss out on any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, requesting features, giving feedback, reviewing our product roadmaps, attending in-person events, or joining webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. We have a fascinating topic for you today. We will be talking about deploying and configuring Azure Advanced Threat Protection. I'd like to introduce you to our presenters, Banu Jafarli and Gershon Levitz. They are members of the Azure ATP product team, so they have deep expertise in this topic. Without further ado, I will turn it over to them. Gershon and Banu.
Thank you, Ryan. So my name is Gershon Levitz. I'm with the Azure ATP customer experience on the product group team. So I'm working with customers and partners supporting Azure ATP. And today we'd like to bring to you from our experiences of deploying Azure ATP and showing you how easy the deployment is and how quickly this deployment can be done, along with some of the best practices for the deployment of Azure ATP.
Hi everyone, my name is Ballinger Farley. I'm a program manager on the same team as Gershon, also on the customer experience engineering team in the product group. Today we'll be going over a quick understanding of Azure ATP and what that is. Then I'll show you guys a quick and simple deployment of Azure ATP. We'll cover requirements and best practices, what you can do post-deployment, and next steps. So what is Azure ATP? Azure ATP is a cloud-based security solution that leverages your on-premises Active Directory signals to identify, detect, and investigate advanced threats, compromised identities, and malicious insiders that are trying to get into your organization. So what makes Azure ATP unique? Well, Azure ATP uses real-time data. It looks at network traffic, trace data, and events to find anomalies quickly. It uses a combination of behavioral known attack techniques as well as security signals. Because we're really focusing and using network traffic, we can do a deep packet inspection with all the layers of the network package. By extracting that information, we can provide the closest thing to the truth. Events alone are not enough, and Windows events can be both deleted and modified. It's very difficult to work off event data for advanced detections. We're also providing you with real-time alerts and monitoring, and as well as user and entity enrichment. We're trying to help you understand all the information about your users, the accounts and resources they have access to. In addition, we're providing you with a lateral movement path so you can identify when a single credential has been compromised and when an adversary is moving laterally in your environment to get access to a privileged account. This helps us understand the path where the weak points are so we can go ahead and break those weak points and make sure you're protected. And of course, we're using best-in-class security. Now, the goal with Azure ATP is to detect the stages of an attack early on and get rid of an attacker as quickly as possible with as little damage as possible. So an attack begins after an attacker has made that initial foothold in your network. After that initial compromise, they're going to be performing reconnaissance to get a map of your network, your users, your IPs, and your domain controllers. And these are the type of techniques Azure ATP will alert you on. In the next phase of the kill chain, once the attacker understands which users they can compromise, they will try to use techniques such as brute force or trying to connect to a honey token account, which is just a dummy user with no network activity but has an attractive or enticing name. And we can see that when an attacker is in your network. If they're able to compromise the credential, the next thing they'll do is move laterally in your environment. And Azure ATP will help us understand the techniques they're using to try to move laterally in your environment. If the attacker is able to gain access to the privileged account and go into the domain dominance phase, which is the next phase of the kill chain, they'll be doing that using techniques such as skeleton key, DC shadow, or golden ticket attack. And Azure ATP can go ahead and detect those techniques as well. But the goal again is to find that attacker early on in the reconnaissance phase before any damage is made. And that is the true goal of Azure ATP. Find those attackers early on and make sure as little as much damage is made. So next I'll be talking to you about the Azure ATP architecture. So there's different pieces that we have. The first piece that we have is the Azure ATP Cloud Service. It runs on Azure infrastructure and is scalable. The Azure ATP Cloud Service is also connected to the Microsoft Intelligent Security Graph. Then we have the Azure ATP sensor, which is installed directly on your domain controller. It will only extract the required information needed for the detections and send it over to the service. The Azure ATP sensor is the one that's doing all the heavy lifting. It's doing the inspections and the extractions of network activities from the Windows events we're looking at, and then going ahead and sending them to the Azure ATP service. Then the Azure ATP service, that's the brains of the entire operation. It's where the detection engines are running, and it's the place where the admins will connect to and get the information that they need. This is also where native integrations come in with the Windows Defender ATP, for example. The Azure ATP portal will go ahead and display the data received from the sensors, show you the detections and then the evidence needed so you can go ahead and understand that information in your environment. So next, I'll be walking you through a quick demo to show you how easily Azure ATP can be installed on your sensors. We've had customers with over hundreds of domain controllers install this in a matter of days. So let's go ahead and get started. So here I'm in the Azure ATP console, and the first thing I'm going to do is create our Azure ATP instance. And this is going to take a few minutes or seconds. Now that I have my instance, the next thing I'm going to do is provide a username and password. And I went ahead already and I created a directory services user on my domain controller. And this user is going to be running LDAP queries against the domain controller. So it needs to make sure that it has read access. So I'm going to put in my username. My password and the domain that it's part of. And I'm going to go ahead, scroll down and save this. Now the next thing I'm going to do is download the sensor setup. And here you can see the access key. This access key will be used throughout the sensor configuration. There's no need to regenerate it. So I'm going to go ahead and press download. And once it's downloaded, I'm going to go ahead and save the deployment onto my desktop, the setup. Now I'm going to go to my desktop, and we have to make sure we extract the files. We can't just do the installation from a zipped file. So here you can see my Azure ATP sensor setup. It's already been extracted, so I'm going to double click on it and run it. Next, and then the next step, it's going to ask me for my access key. So I'm going to head over back to the console and copy over the access key. Go back to my installation of the sensor, paste it in, and start installing the sensor. So what we're doing here is by providing that access key, we're helping the sensor to go ahead and communicate from the domain controllers to the service and send the information over. So this takes a few minutes to go ahead and install. It's a very fast installation. Like I said, we've had customers do this with hundreds of domain controls in a couple of days. And as you can see, it's already completed. So I'm going to go back to my portal, just refresh the page. And you can see here that the sensor is starting and it's going to be in running mode next. So you can already see the name of my domain control, and you can see that the sensor is currently starting. Now the last step of the deployment, now that you can see how quick and easy it is going ahead and integrating with our new identity and threat investigation experience. So here I'm going to go to the Microsoft Cloud App Security portal, and what we've done is create a new threat and identity investigation experience that combines your on-premises identity data as well as your data in the cloud, and it's using the MCAS infrastructure. As you can see here, I have a blank console. It says here I can protect my Active Directory identities with Azure Advanced Threat Protection. So I can go ahead and turn that integration on. And you don't need to have MCAS licensing to use this infrastructure. And by turning on this integration, we'll be sending our Azure ATP alerts as well as activities into this console. So if I go into the gear and go into my settings, click on Azure ATP, just a second. Come in here one more time. Go back into my settings. And here I have Azure ATP. And once I turn on the Azure ATP integration, within 12 hours, all my alerts and activities from Azure ATP will go ahead and feed into the MCAS console. And like I mentioned, you do not need to have MCAS licensing to leverage this integration, but this is what your one-stop shop for your identity alerts and activities, both on premises and in the cloud. We're also leveraging Azure AD identity protection information here as well. Now I'm going to go ahead and Gershon's going to follow up with best practices for deployments.
Thank you, Manu. Thank you, Manu. So we see how quickly and easily that we can actually deploy Azure ATP, and now we also have the integration with the MCAS, with the investigation and threat protection. So now we're going to talk a little bit about some of the best practices. So we're first going to start with some requirements and best practices for deploying Azure ATP. The first thing I want to talk to you is about the Azure ATP sizing and advanced audit tools. Azure ATP has been redesigned and is very, very resourced. We don't use a lot of resources, but we still need to make sure that our servers are properly sized. In most environments, in a lot of environments, you can actually just deploy Azure ATP. But if you want to, you can actually download it and run the Azure ATP sizing tool. This is going to confirm for you that the domain controllers support the deployment of the sensor on them. And you can actually run the tool against either a single domain controller, just to get to see how the tool works, against a single domain in your environment, or against all of the domains in a forest if you have a forest that actually has multiple domains that are part of it. The nice thing about the tool, the output of the tool is an Excel file. And the nice thing about the Excel file is that you can actually now sort your list of domain controllers. Will give you a list of all the discovered domain controllers, and you can actually sort this either by AD site, by operating system version, or whether it's physical or virtual. And we're going to see further on when we talk later, we're going to talk about sometimes there's some things that we need to do on the virtual machines if the domain controller is running on VMware. So this will actually give you some of that information. It helps you with your deploying planning for Azure ATP. The other tool that we should be running is the advanced auditing tool, and we see the link here also. Azure ATP, not in addition to the network traffic that we're doing the deep packet inspection, we have about 8 or 9 Windows events, security events that we're actually using to help us enhance our NTLM and also understand who's making changes to specific security groups. To ensure that the domain controller is actually recording these events, the auditing tool actually can confirm that the audit settings are properly set in your group policy or locally within the domain controllers at hand. So let's actually take a quick look at what the sizing tool results actually look like. So here I actually have a sample sizing tool. We can actually see the start and end time of the tool. By default, you should let the tool run for 24 hours. The tool is going to make some generic WMI request to gather some information about each of the domain controllers, and then it's going to record a number of performance counters remotely. So we could see we are collecting information about available memory, installed memory, CPU, number of processors installed, and then we could also see the VM indicator. Is this a VMware Hyper-V or is it a physical machine? We could also see the AD site, so we can actually start to do our rollout based upon the site and then sort based upon the site, the various sites that you have in the environment. The other thing we could actually see is the version of Windows that's installed. And then if we go in the beginning, we could actually see, is the sensor actually supported? So here we see I have an environment that has 11 domain controllers. We can see that 9 of them are actually supported, and we don't have to do anything. We could actually just start our deployment. One of them we can't deploy to, and we'll take a look at the reason why in a second. And the last one is that we need some additional resources. We need to add some memory to this domain controller. And we're actually looking at this, and we're seeing, we can actually see that the average memory and the minimum amount of memory might be too low. So we could actually look at to see what else is running on this domain controller. We can deploy the sensor and see if we really need those resources. If we start to run into resources issues, this sensor will actually limit. We actually monitor and we limit the number of resources that are available to the sensor so that the domain controller continue to function as providing authentication and authorization services. You will receive an alert if the sensor of Azure ATP doesn't have enough access to resources to give you an indication that you need to add some more resources. So let's look at DC10, which we actually said the sensor is not supported. And in DC10, we actually see that it's not supported because we are running a version of Windows that's not supported anymore. So it's Server 2008. I actually have some customers who've run this report has actually come out and found that they're actually running servers that are domain controllers on Server 2003, and that surprised some of the people within the environment. So Azure ATP supports Windows Server 2008 R2 Service Pack 1 and higher. So this is a domain controller that we would not be able to deploy the sensor to. And this would be a good indication of a time to either upgrade this domain controller to a supported version of Windows at this time. So let's actually go back to the deck. So now we're going to talk about OS level requirements. So Azure ATP sensor requires .NET Framework 4.7, and the installation of .NET Framework 4.7 on a domain controller will typically cause a reboot of the domain controller because the Azure AD Web Services is typically using the .NET Framework, and to update those services, the .NET Framework, we would need to either stop the Azure AD Web Services or do the deployment during a maintenance windows. And the important thing here is that if .NET Framework 4.7 is not installed on the domain controller when we install Azure ATP, the Azure ATP installation, the sensor installation, will go ahead and install .NET Framework 4.7. And this might cause a reboot of your domain controller while you're doing the installation, and probably not something we want to do during production hours. And if you are doing a silent install, a lot of customers, once they see how easy it is to actually deploy this, and very quickly they will do this via command line prompt and script this out. It's really important to make sure that this .NET Framework is actually installed before we actually start the deployment of the Azure ATP sensor. For Server 2019, we require the following KB to be installed. Otherwise, we're not able to install the Azure ATP sensor on Server 2019. The other thing in terms of OS settings is we really should have power options set to high performance. We're running domain controllers. These are servers that are critical to our infrastructure. The Azure ATP sensor needs access to resources at the same time that so does the LSAS service. So let's actually set the power options to high performance. This ensures that all of the CPU and memory is available at the same time. If we're running at balanced, think of it almost as, buying a Ferrari and driving it in economy mode as opposed to sports mode. So we've actually seen with some customers who haven't done this, and we have seen some health alerts. And once we've actually enabled high performance on the power options, all the resource requirements sort of went away. The server was actually performing better than before Azure ATP, the sensor was actually deployed to it. The next item to talk about is the directory services account. And as Banu mentioned, during the installation, we need to configure the directory services account. This is an account that's actually going to that performs a number of functions. The first function is going to be doing, as Banu had mentioned, is perform LDAP queries against the domain. And this is actually so that Azure ATP understands of all the objects, users and groups and computers that are in the domain. And to do that, we actually need to be able to have read permission to all the objects in the domain. The second item that the directory services account is going to be doing is when the sensor actually sees network traffic coming from a specific IP address, we're actually going to connect back to that IP address, excuse me, to get a list of all of the existing members of the local administrator group on that computer. And this helps us build a feature that we call lateral movement path, which enables us to see if there is a potential path to a sensitive user, to a user who has elevated privileges. Without being able to see this information, we would not be able to provide you with these lateral movement paths. And these can, one, be very helpful in terms of making the environment more secure by understanding where these paths exist and removing them. And two, if you are doing an investigation for an incident, you could actually see potentially the path that the attacker took to compromise a specific user account. So in a forest with multiple domains, we only need one directory services account. But recently we added multi-forest support. And if we have a multi-forest environment with a two-way trust, we can still use a single directory services account. The only time that we actually need to add an additional set of credentials for a directory services account is if we have multiple forests with no trust relationships, or if the trust relationship is built with a non-Kerberos trust. And in that case, we would just need for each forest that meets those requirements, we would add another directory services account. By default, you can add 10 directory services accounts to the Azure ATP console. In the same place that Banu added that initial directory services account, there's a button there that will say add new directory services account. By default, you can add 10 directory services accounts. If you do have an environment that you have that you need more than 10, please contact support or contact us, and we will help you. We'll be able to increase that number beyond the default limit of 10. The other thing to keep in mind when we're doing the deployment of Azure ATP is what are the requirements that we need from in terms of ports. So the first port is that the sensor needs to talk to the Azure ATP service. As Banu explained in the architecture, the Azure ATP sensor is going to be doing deep packet inspection, extracting out the information that we need from the network traffic, and send that information up to the Azure ATP service. This is happening on port 443. It is encrypted. And to make it as secure as possible, we can actually specify a single URL specific to your organization that you need to open up in your proxy. So you just need to specify the Azure ATP instance name, sensorapi.atp.azure.com, and that will allow, and that is sufficient for communication of the sensor to the Azure ATP service. We're going to talk in the next slide a little bit more about that and how we're going to actually make that, get over some thoughts about not opening up the ports for the domain controller. But right this second, this is what we need to have open. Internally, what we need is the sensor needs to talk to the DNS servers. Since the sensor is going to be installed on the domain controller, this should be automatically opened already. The sensor needs to talk on port 445 to all the devices on the network. And this is used to query the machines for the local membership that I spoke about before to be able to build the lateral movement path. The next three items that we actually have on here is the the sensor talking to the internal on the devices on the internal network for on port 135, 137, or port 3389. And this is used as part of our network name resolution process. So when Azure ATP sees an IP address in the network traffic, we are going to resolve that IP address to a computer name. And then we look up that computer name in LDAP, that's our LDAP connection, and we're going to be able to see and then match that computer name that we get. So what we're going to do is we're going to send out a packet on these ports, and we're going to see that based upon the information that we receive back, we can actually make the determination what the computer name is and then match it to an object in Active Directory. This allows us to have, with a high level of confidence, be able to have detections like pass the ticket. So we can actually see when a Kerberos ticket was issued to computer A on IP address 1, and when that IP address changes, we can still resolve that back to computer A and understand that that's not a pass the ticket. But if we see that the IP address's name is now computer B, that would be a trigger for us to raise a pass the ticket. And the last two items is radius accounting. So if you are using VPN server, you can send us from the radius accounting server. You can send this is going to be an inbound from the radius accounting server into one of the sensors. And the other one is the sensor sending out traffic to your SIM or syslog server. So we define a single domain controller to connect to the Azure ATP service. It's already connecting there, and it's one additional task that will be added to it is to pull down the alerts and send that to your SIM that is on premise. And you would then configure based upon the ports and the protocol that your SIM is using that you've configured to receive that information from.
I just want to clarify that for the ports relating to network name resolution, you only need at least one of them to be available. It is not required that all of them will be available and opened. Thanks, Gershon.
Tali, thank you for that clarification there. Okay, so the question we hear a lot from initially when we start saying, oh, we need to open up the sensor to the domain controller is we have a best practice that we don't want to install. We don't want our domain controllers communicating to the internet. And at this point, the conversation turns to if you're using a proxy, the domain controller is actually communicating to the proxy, and then the proxy session is going to the internet. So the domain controller still does not have a direct connection to the internet. Additionally, as I mentioned before, we could also limit this connection to a specific URL. So if we set up a proxy rule to say, so in my example that we have the CXP Ninja tenant. So we could actually, in our proxy, we could set up a rule that says allow from the domain controllers to the CXP Ninja sensor API.atp.azure.com. Just note that there's no period between the instance name and sensor API. It's one word that's actually there. And at this point, we've just made it so that the domain controller can only communicate through the proxy to this one URL within the Azure space to the Azure ATP service specifically for that tenant. At this point, we're I don't have a single customer, large or small, who's come back and said, okay, this is going to stop us from deploying. Additionally, we actually now recently added the ability, and this is in preview, the ability now to actually configure the settings and do authenticated proxy support. So now we can actually configure during the installation of the sensor from the command line, we can actually specify a proxy URL, a username, and a password. And this will allow us now to say that only traffic coming from this username, and we could also then add from the domain controllers, will we allow traffic to go out to the internet. And you can see an example of what the command line would actually look like in terms of deploying it. And username and password is optional, but for customers who requested that they wanted to be able to do authenticated proxy support, we actually provided them with this option. NIC teaming. A number of our customers have NIC teaming deployed on their domain controllers for high availability. And the sensors by default that will not function properly on a domain controller that has NIC teaming configured. NIC teaming is typically going to be on physical servers. If you have NIC teaming configured on virtual servers, we can probably have a conversation on why that's, how effective or ineffective that is. But either way, we have some of our customers do have physical servers that are running NIC teaming on their domain controllers. So the fix for that is that during the installation of the sensor, we actually are deploying the WinPCAP agent. So instead of using the WinPCAP agent, we need to download and install the NPCAP agent before deploying the sensor. Initially, NPCAP, if you look at the licensing agreement from a few months ago, the licensing agreement, the free version of NPCAP, has a limitation of 5 deployment on 5 different servers before you actually need to purchase a license for it. This limitation, as we made our agreement between Microsoft and NPCAP, we no longer have that limitation. And if you're using the Azure ATP sensor, you can deploy NPCAP on any number of servers that you actually want. And we can see here that this 5 copy count does not apply to when you're using advanced threat protection, the Azure ATP sensor software. If you need the OEM version of NPCAP, you could contact us and we can actually get you a copy of the OEM version. The OEM version is really only going to help us when you actually have a large number of servers to deploy NPCAP to, and you actually want to script the deployment of NPCAP. As I had mentioned before during the talking about the Excel file on the Azure ATP sizing tool, one of the things that we've actually seen there is a small little thing that we start to get when the domain controller is running on VMware, and we have we'll start to see drop packets health alert. And this happens to do just with a quirky thing that happens with VMware when we're dealing with large send offload is enabled. And the trick here is if you are running your domain controller on VMware, you just need to disable the large send offload setting. And it's actually very easy, and we can actually just grab that list from our domain controllers from the Azure ATP sizing tool, and we can actually do a very simple PowerShell command to actually see if the domain controller is configured for large send offload, and you can see the command here, and then you can actually see where it's actually enabled. And then to actually just simply disable that is going to be disable the following command with the name of the adapter on that specific domain controller. Once this is enabled, those virtual machines will stop with the dropped health packet alerts, and everything will be fine. This has very, very minimal, if any, impact on the domain controllers. Customers who are running this after they enabled it, they didn't notice any difference in the performance of the domain controller. So let's talk about post-deployment. So hardening, as we mentioned already a number of times, let's use a single URL to open the sensor connectivity. We don't need to open it up to all the internet. We don't even need to open it up to star.atp.azure.com. Let's just open it up to the name of your sensor, name of your instance, sensor.api.atp.azure.com. The question I get from a lot of my customers is on the next item is I want to limit access to the Azure ATP console to specific locations, or I want to block access to the Azure ATP console to specific users. And this can all be done with conditional access policies. So we will configure a conditional access policy, and using the power of Azure AD conditional access policies, we can actually enforce MFA, we can block access. And in this way, I can say users are only able to access the Azure ATP console, which is a Azure service, if they are on my premise or on my VPN server, or are required MFA, so that I know it's really them before giving them access to the Azure ATP console. The next item that we have here is, again, just a reiteration of the Azure ATP directory service account only requires read access to the objects in the domain. The Azure ATP service account, this directory service account, should not have does not need elevated privileges. It just needs to be able to read all the objects that are in the domain. And also, it needs permissions to make the remote SAMR queries against the local machine, the workstations in the environment. So with that, I'm going to hand it back over to Banu to actually do a short demo on the Azure AD conditional access for the access to the Azure ATP console.
Yes. So I have a user here, her name is Megan. I'm going to go ahead and log in as her to show you that right now she currently does have access to the Azure ATP console. Oops. Did I go back in? Okay, so you can see here right now, we're currently logged in as Megan, and I'm going to go ahead and create a conditional access policy to block her access. So I went ahead and already started creating this policy. So the first thing that you need to do is actually specify which users you want to scope this policy out to. At this point, I only have it scoped out to Megan. Then the next thing we have to do is choose our application. So I went ahead and chose Azure Advanced Threat Protection. And you can choose the various conditions that you want this policy to be applied. In this case, I just want Megan's access to be completely blocked. So in my grant, I just said block access, but you can also grant access but require additional authentication methods such as MFA or requiring them to log in from a hybrid Azure AD joint device. At this point, the policy is off, but I'm going to go ahead and enable it and save it. And the next time we log in as Megan, her access will be blocked. Okay, so now you can see the policy is enabled. I'm going to go ahead and close this window out and create a new and private window. Go back into the Azure ATP portal. And try to log in as Megan again. And as you can see, it says I don't have access to this. So now Megan's access to the Azure ATP console is completely blocked. But as I mentioned, if you want to have additional authentication methods for your users to get access to the console, you can do that as well. Now I'm going to give it back to Gershon.
Okay, thank you, Bono, for that. So we could actually see how easy it is to not only deploy Azure ATP, but also to control access to the console using conditional access conditional access policies. So let me just share my screen out again. Okay. The next step that we typically get into is going to be validating your deployment. So typically when you first deploy that first sensor into your Azure ATP instance, it takes about 15-20 minutes before actually everything gets started and we're building some backend infrastructure. And this is just on that first sensor that's actually getting deployed. So one of the things that I actually typically do with my customers is I'm actually going to do an NS lookup to validate that the sensor is actually recording the network traffic and is then being able to see it. So what I would typically do is I would go into one of the machines in the environment. I would open up a command prompt and I would type in NS lookup. And this actually connects me to DNS, and there are a number of queries that I can do directly from the NS lookup command prompt. The next thing I'm going to do is I'm going to connect directly to my domain controller that I just installed the sensor. So I'm going to say Contoso DC.Azure in this environment. Not sure what's happening on that. But what I'm going to do here, since I'm actually connected to this domain controller, I'm just going to do an ls command, which is a zone transfer, -d, and I'm going to say Contoso Azure. And we're actually going to see that the query has actually been refused. So that's actually a good thing. So now let's actually take a quick look at see what's actually happening. And I'm actually going to show this to you of what's happening in the after we've enabled that integration with Cloud App Security with the new console experience. So if I'm looking at the activity log, what I typically have my customers do is create this query. So I'm looking for I'm looking at the application being Active Directory, which is the Azure ATP information. The activity type is equal to DNS query. I'm going to say the device is equal to Contoso DC, which is my sensor that I have deployed on this machine, and it's going to be the destination. So in our case, this is the destination of the traffic. And then I'm looking for any traffic, I'm looking for any object that has a AXFR, which is the zone transfer in DNS language. Now, if I would actually deploy this to a second sensor, I would actually just change this server here to that name. And we can actually see here, and let's actually see if the demo gods are on my side and see if this gets updated to 5 something. Might take another second or two before this actually gets updated. But one of the nice things is that I can actually create this query and then I can actually save it. So I can come back into this as my deployments are taking place, and I can come back on and look at the existing saved queries. And if I look at the saved queries, I have my sensor validation, and I put a note in there to say change DC name. And we can now see, now if we actually open up one of these, we can actually see what's actually some additional information. We could actually see that it was a DNS query to contoso.azure. We can see that the protocol type was a zone transfer. We could see that it was false, and the reason why it failed was connection refused. That was we just saw previously before within the zone transfer command. And this is actually, and we could see that it was actually taking place from the victim PC. So this was the machine that I actually did this on. You could also create a policy from this query so that you could be alerted if there are zone transfers coming from specific machines with the environment if you want to. We have our own logic that we build based on some machine learning and behavioral analytics that will actually alert on suspicious DNS queries that are coming in. So this is a really easy way to actually validate that the sensor is up and running. Besides going into the console and seeing the status there, this really gives us some additional confidence that things are working the way that they should. So these are just my backup slides, just in case that's actually going to work. The last phase that we actually spoke about is going to be enabling the identity threat investigation experience that Banu already took us through. And this is going to enable us to investigate based on priority score and alerts and suspicious activities. And it also gives us, if you do have Cloud App Security, and as Banu had mentioned, you don't need to take advantage of the new infrastructure. You don't need to have Cloud App Security, but if you do have Cloud App Security, along with Azure ATP, we'll also start to be able to see in a single location the activities of your users, both on-premise and in the cloud, and also start to bring in alerts from the Azure AD Identity Protection Center. The third thing that you can do here is also now start to create custom policies based upon the Azure ATP activities. And this is something that a lot of my customers have started to do, being able to now be able to create a custom policy based upon these activities that we're actually seeing, and match the activities from Azure ATP if there's something specific that they actually want to be alerted on. We actually had a few weeks ago, we actually had a seminar, a webinar where we actually, where Yossi, my colleague, actually talked about the new identity threat investigation experience. And if you click on this, if you go to this link, you'll actually be able to see the recording of that session. And again, this is just the UI, and it's a single click. And even though it does say it's going to take some time to get in there, within a few hours, we should start seeing some of that information showing up. The next thing I'd like to do is actually plug our next webinar. And this is a webinar on the identity security posture assessment management webinar. So we've actually added to the cloud app to the infrastructure of cloud app security a number of reports that allow us to assess and reduce the on-premise identity attack surface. This webinar will be taking place next Tuesday on September 24th. Depending upon your time zone at those times, you can register for using the following AKMS link. And this is actually something that was actually just released in public preview, and you could actually see the documentation using the following short AKMS link. Before we open up for some questions and see what questions are being asked and leave some time for questions, here are some next steps. So you can learn more about Azure ATP through our technical documentation. Coming soon, we will actually be publishing the Azure ATP deployment best practices document. This is the link for it. I'm hoping really to have this by the end of this week. If you don't have an Azure ATP license, you can actually start a trial by clicking on this link. And of course, as Ryan had mentioned earlier, the last two items, join the conversation. We are all very active there from the product group team on the technical community. And to view our past webinars, again, you can go back to this link here. Okay.
Great, thank you, Rashawn. Well, so I want to give people just another reminder here. This is your chance to ask additional questions that I'll then read aloud to Gershon and Banu, and they can elaborate on them. So please get those typed in the IM window. But I had something I wanted to raise up here. You covered a lot of various configuration scenarios and a lot of different ones like that. But based on Banu's demo, in the simplest scenario with just one or a handful of DCs, it looks like you could deploy Azure ATP in just a few minutes. Is that correct?
Yeah, so you could actually deploy Azure ATP really quickly. I mean, that was a demo environment, but I've had customers deploy, hundreds of domain controllers, over, a 1 week period. And initially you started out slowly. They do a phased approach to the deployment, starting out with a few domain controllers, seeing how the process goes, and then, kicking it up, slowly but surely, and really just going out for a full deployment. And that could be done, depending upon the size of the environment, from days to, a week, maximum a week and a half.
Great, thank you. We've had a whole bunch of questions around licensing. Can you give a quick explanation of what licensing is necessary?
Yeah, so Azure ATP is part of the Enterprise Mobility and Security Suite, EMS Suite, the E5 Suite. It is also included as part of the Microsoft 365 E5 Suite. And additionally, a customer could purchase Azure ATP as a standalone licenses.
Okay, great. We've got a question. Can a trial be started with an MSDN subscription?
If they have access to the EMS E5, they should be able to. I'm not sure. That's something I would to be 100% sure. We'd have to get back to that. We'll put that into the question and answers on the tech community site.
Thank you. We've got a question here. We are only using Azure AD online, not from a physical server. Is it possible to deploy Azure ATP?
So if they are running Azure AD as virtual machines in Active Directory as virtual machines, either in Azure or AWS or other hosting service, then yeah, we would just need to install the sensor on the domain controller virtual machine. So in the demo that Bono did, that's actually a virtual machine that's sitting in
Azure.
In Azure. So if they are using the Azure Active Directory services, that is we cannot install the sensor there. So that is something that we would not be able to monitor at the moment.
We've had several questions around differences between ATA and Azure ATP. Can you elaborate on that a little bit?
Eyal, do you want to take that, or?
Yes, sure. Hi. Yeah, was just answering another question. So a good question regarding the difference between ATA and Azure ATP. And in fact, there were also several questions around that here in the chat. And there was one session that was asking whether there are any gaps between ATA and Azure ATP. And the answer is that yes, there are many differences for the sake of Azure ATP to include many additional functionalities on top of ATA. And let's try to enumerate 2 or 3 of them. The first one is ATA is installed in the on-prem. Think about ATA as an island. You are managing the management. It has no interactions to get feeds from other Microsoft security solutions. You cannot hunt across data from other data sources. It is what it is, just the Azure ATP signals, the ATA signals. Azure ATP, as Gershon is now showing, is integrated with all Microsoft 365 security solutions, and you can build policies and hunt and make queries and look for alerts and incidents across all of these solutions together. The second elements are with detections. Azure ATP detections are done in the cloud. It gives us the ability to reason throughout a lot of more information, to do our security research in by far more effective way, and by that update the product on a weekly basis. So every week in Azure ATP, we're providing new detections, new capabilities, fixing bugs if needed, and by that you get new capabilities on a weekly basis. ATA is on-prem solutions, and as an on-prem product, we have the ability to provide a hotfix for that roughly twice a year. These are the big elements. So one of them are in terms of new detections and additional features and capabilities. The other one in terms of scalability, and the last one in terms of the interoperability between this product and other Microsoft security solutions. We do recommend, if you are standing right now and thinking whether you'd like to look at ATA or at Azure ATP, if your business is a hybrid organization, you're thinking about cloud identities, you're thinking about protecting your endpoints with Defender ATP, then the right solution for you is the Azure ATP by any means. Thanks.
Great, thank you for that. I want to give people here, as we close up, a couple of reminders on some additional links. If we somehow missed your question or were unable to get to it, please go to aka.ms/Azure ATP community. We can answer additional questions there, or if you're listening to this as a recording, that's the place to go if you have follow-up questions. To get to the recording, go to aka.ms/AATP recordings. We have both, we'll have both this one there up today, and we have ones from past webinars there as well. To join our general security community, which has several other products involved in addition to Azure ATP, go to aka.ms/security community.